Welcome back. That was quite a marathon video, that last lesson there, but we're going to continue on with our exploration here for the fourth lesson in Module 3, where we're looking at the graph of a quadratic function and its characteristics. Exploratory Challenge 3 here is what we're going to be covering. So below you see only one side of the graph of a quadratic function. Complete the graph by plotting 3 additional points on the quadratic function. Explain how you found these points and then fill in the table on the right. So how are we supposed to use this graph that we have right here to get more graph? Well, remember that these quadratic functions are symmetric, right? We have this line of symmetry where a point here reflects over to a point right there, right? And a point right here reflects over to a point right there, right? And so we can utilize that here as well in our graph where we only have half of the quadratic. So what does that mean? Well, if we were to extend things here a little bit, pardon my sloppy drawing here, but you get the idea. Okay, and then I'll just try and graph in some extra grid lines here. So this would be 1, 2, and 3 right there. And so this point, right, here's our axis of symmetry right here. Maybe I should put this in a different color. Let's do it in blue maybe. I'll make it thicker too. So our axis of symmetry is the y-axis. So, and I'll do the other points here in green. So this is 1 away there. So that means we're going to go 1 away over here, and there's our next point. So the point is 1, 2. Here we are 2 away, so we go 2 away here. So we're at 2, -1. And then here we are 3 away. So 1, 2, 3 away is right there to that point. And we can connect the rest of the graph there to finish it off. Okay, so what are those coordinates? Okay, they are, well, we'll start with the first one, -3, this right here, -3, -6, then -2, -1, then -1, 2, then 0, 3, then 1, 2, then 2, -1, and then 3, -6. Okay, you can see that symmetry right there. Okay. What are the x-coordinates of the x-intercepts? Interesting here, right? If you look at this graph, it's not very clear what those x-coordinates are for the x-intercepts. Okay, so we'll have to come up with an equation for this, which it didn't mention before yet. So we're going to hold off on that question for right now. The basic way that we would have to do this would be to, I think the equation here, let's see. Yeah, they're not nice numbers, okay? So you can roughly estimate those to be about 3/4 and -3/4. They're not actually going to be 3/4 and -3/4 here. So we're going to hold off on that question for right now. We'll skip it. Okay. What are the coordinates of the y-intercept? Well, that's what we can see right here. Okay, so 0, 3. What are the coordinates of the vertex? Also 0, 3. Is it a minimum or a maximum? It's a maximum. Okay, go ahead and try and answer the rest of these questions here on your own. See what you can come up with before I answer them all. Okay. If we knew the equation for this curve, what would the sign of the leading coefficient be? Well, it's opening down. Since it's opening down, we know that A is going to be less than 0. In other words, negative. Verify the average rate of change for the interval is 5. Show your steps. Okay, so we're going from -3 to -2. So we're going from this point right here to this point right here. Okay, this coordinate is -3, -6, and this coordinate here is -2, -1. Okay, so then slope formula. y2 minus y1 over x2 minus x1. So we get 5 over 1, or just 5. based on our answer to row 6 in the table for Exploratory Challenge 2, what interval would have an average rate of change of -5? All right, well, let's see here. So Exploratory Challenge 2, row 6. Let's take a look at this thing. This is dealing with increasing and decreasing intervals here. Okay. I don't think that quite works here, but again, we can use symmetry. So from these 2 points, we went up 5 and right 1. So then use symmetry here. From these 2 points, we're going to go down 5, or, right 1 and down 5. And so it's going to be at these 2 points at 2 and +3, just using the symmetry there. Like that. Okay, just using the symmetry of the graph. Whew. All right, we made it to the end. So the summary for this lesson: quadratic functions create a symmetrical curve with its highest maximum or lowest minimum point corresponding to its vertex. So the maximum or minimum is at the vertex. And it depends on whether, if A is less than 0, we'd have a maximum, or if A is greater than if A is greater than 0, then we have a minimum. Okay. And an axis of symmetry that passes through the vertex, the x-coordinate of the vertex when graphed. The x-coordinate of the vertex is the average of the x-coordinates of the zeros of any 2 symmetric points on the graph, or the midpoint, too. You can think of it that way, the midpoint. When the leading coefficient is a negative number, the graph opens down, like this. Okay? And its end behavior is that both ends move towards negative infinity, right? Because they're both pointing down. When the leading coefficient is positive, the graph opens up, which looks like this, and both ends move towards positive infinity. Again, you can see because those up arrows there. Okay, so that's our lesson on the characteristics of quadratic functions. We'll see you next lesson.